Okay, so a student of mine named Zale was working on this question here for extra credit and was frustrated with the prospect of trying to add the sequence of fractions here. We have 1/2 plus a fourth plus an eighth and a 16th and a 32nd, right? We're halving these fractions each time until we reach, let's say, a 64th. And this was frustrating because the only approach that we can come up with at the point was to find common denominators and somehow add this. So I just want to step back and talk about this problem because I think it's just so wonderful that there exists such a simple solution for this problem if we just look at some basic patterns here with I'm going to use area models. When you get a problem like this, let's just say that if you're totally stumped, what you want to do is break it into smaller chunks. That's usually my approach. So here, that smaller chunk for me would just be like to say, okay, well, what's a half plus a fourth, right? So typically we might find a common denominator and show that this is equal to 3/4. But let's try to find another way because we don't want to use the common denominator method, right? That's not going to help us in this problem. It would be too frustrating. We could do it, but it would be very tedious. So another way that strikes me is if we think of this square right here as being our whole area. We first think of a half. What we're doing is splitting the area into equal pieces, right? So assume I've done that equally. It's certainly not exactly right, but okay, so here we have a half of the total area, right? And that's this piece right here. We can label that as 1/2. Okay, but then what do? Well, we add a fourth to that. Well, let's just add that into the remaining region, right? Because when we have a half and a fourth, it's like taking this half and then adding a fourth to it right here. So now, if you think about what a fourth would represent, it would represent half of the remaining area, right? So this is a fourth. Okay, so we have a half and a fourth. And if that was the case, right, and we wanted to add up these two, we could see that it's 3/4 of the total. But another way to think about it, and what kind of struck me here, was that how much less than the total, right, is our sum? In other words, if by total I mean total area, how much less than the total area is a half and a fourth? Well, that would be equal to this space right here. So I wondered a lot about this space right here and thought, well, what does this equal right here? And what I noticed was that, yes, a half and a fourth. We add them up, we get 3/4. But that also means, and you can think about this, if we have 4/4 in total, and subtract what we have with a half and a fourth, that's 3/4, the remaining piece here is equal to what? Well, if we have 4/4 in total and 3/4 so far, this empty space must represent 1/4. And maybe it doesn't really strike you as being interesting yet, right, that this space equals a fourth, but let's try the next sequence. So we tried the first two fractions, let's try the first three fractions. Now let's look at these fractions right here. What if the problem was, instead of a half plus a fourth, a half plus a fourth plus an eighth? So we can certainly still use our common denominator strategy to figure this out. We can turn them all to eighths, right? A half would be 4/8, this would be 2/8, that would be 6/8 plus an eighth, that's 7/8, right? Altogether 7/8. But let's look at a similar type of area model to make sense of what's happening here. Okay, I'll try to. Okay, so this time we have this area model, and let's say first we have 1/2. So we can think of splitting this model in half, just like we did before. And this time I'm going to just color with my paint tool there. Oops, that did not work the way I wanted it to. I guess I didn't close the line. Let me try that again. So we have this half right here. There we go. So we filled up half of the area. We can label it as a half. So let's label that real quick. Right? This is 1/2. Okay. But we're adding a fourth next. So let's add half of what remains. So there's that area right there. This is our fourth. And we can represent that just by writing the fourth in there. So you have a half and a fourth. Now what happens, and this is important because we want to look for patterns here. We don't want to add up all of these denominators. We want to come up with something powerful here that we can apply to multiple situations. Well, next we're adding an eighth. What is an eighth really? Well, an eighth is half the size of a fourth. So if a fourth took up this area right here, you can imagine that an eighth would fill up half of the remaining space, right? So that means now that this little piece right here, oops, again I didn't close it, but this piece right here, coloring this time, this is the 1/8. And now maybe something begins to strike, right? Maybe you were realizing something that if that's an eighth, well, we add all these up, you can see all the pieces as 7 of the total eighths, and all you're doing there is imagining, let's say, that in this picture, if you can't see it as being 7/8, you would split it into some kind of grid, right? We'll use a different color here. Try to use yellow. Right, if you want to see it there, yeah, this is actually 7/8. What you do is you can cut it up, and what you would get, you see the 8 pieces that fill it. They're each 1/8. So we have, now I know I've used all the different colors here, probably a bad idea, but this is filled up, that's 1/8. These two are filled up, that's 3/8. 4/8, 5, 6, 7/8. So this is equal to 7/8. But then notice, again, the remaining piece. This was the key for me. Here, what is that little piece right there? Well, that's also an eighth, isn't it? So that means that when we add up all of these fractions, a half, a fourth, and an eighth, what's the answer going to be? Well, if we add up all of these pieces, it turns out that the answer is 1/8 less than 1 whole. So that means we could set it up as 8/8 minus 1/8, which is our answer, 7/8. So now we might have something here to maybe work with, right? Because when we added a half and a fourth, right, that our answer was 1/4 less than a whole. When we added a half and a fourth and an eighth, our answer was 1/8 less than a whole. So you can imagine here that if we had a fourth, a half, a fourth, an eighth, and a 16th, what should happen? Well, we're using the last fraction each time, right? When we add up to a fourth, we can look at a fourth and say, okay, well, in total there'll be a fourth left over, right? Because we're adding half each time of each previous fraction. Here with an eighth, there'll be an eighth left over, so it'll be 7/8. Here with the 16th, if we're correct, if our pattern's working, then there will be 1/16 not filled in our area model, or left over. In other words, the answer should be 15/16, right? So let's see if that's going to work here, and then I think we'll be ready to answer the question. So here I'm going to clear this off. All right, so now let's just pretend now that we're dealing with this problem here. We're doing a half plus a fourth plus an eighth plus 1/16. So we set up our area model, right? And what's going to happen is, first we fill it up halfway. Okay, so cut it in half, and that means we've got half of the total area model so far. Oops, wrong tool there. Okay, and that's filled so far, so that's 1/2, of course. Sorry, it's hard to see, but then we add a fourth. Okay, so cut this in half, and we have this area, right? I'll just shade around the fraction this time. That's a fourth. That's better. I should have done that all along. And then again, an eighth is a half of a fourth, so it fills half the remaining area. So now this is filled, right? Okay. Now what about a 16th? Well, a 16th is a half of an eighth. So if this piece represents an eighth, a 16th would fill half of that. Right? Let's say this right here. Okay. And that is 1/16. So what's remaining? Well, if this piece is remaining and it equals this 16th right here, that's a 16th, then we're correct, right? Almost the entire area is filled except for 1/16. So the entire area, we can think of it as 16/16 or 1, and then take away the remaining piece that hasn't been filled in, and you get what is filled in with over 15/16. So it seems to be that if we're adding in this way, a half and then a fourth and then an eighth and then a 16th, what happens is, if we look at the last fraction, that represents not only the last fraction in the sequence, but the exact size of the empty piece in your full grid. So if we're adding, if we go back to our original question, right, is a half plus a fourth plus an eighth plus a 16th and so forth all the way to a 64th. What do we then agree on for an answer? Well, this will represent the tiny remaining piece left in the grid. So what will be filled in the grid is everything but 1/64th. Everything but 1/64th, what's that? Well, 1 minus 1/64th, right? And that you can think of 1 again as 64 over 64 minus 1 over 64, and that equals 63, right? 64ths, the amount that's filled. So everything is filled but 1/64th. And this is just the beginning, really. You can make up other fraction sequences to kind of play with this idea. What if instead of a half and a fourth and an eighth, what if it was 1/3, right? And then you half that to a sixth, and you half that to a 12th, and so forth. Or what if you change this pattern? Instead of a half and a fourth and an eighth and 16th, what if it was a half and then you divided that by 3? So that was plus 1/6, and you divided that by 3 plus 1/18th, and so forth. What would happen then, and how would it relate to this original problem? There's so many fun questions to ask with this, and I do love this question because it's just one of those math questions that seems so complex. But if you change your perspective, you change the way you're looking at it, you change the window you're viewing it through, you can solve it quite easily. All right, so I hope this helped.